Today we're going to be talking about how to talk about polynomials. Now, first of all, what is a polynomial? Polynomial is going to be where you have any sort of variable to some sort of positive integer power. And that power could also include 1, which would just typically be listed as that variable by itself. And it could also include 0, because anything to the 0 is 1. And then any of these can be multiplied by some sort of coefficient, which can either be a also positive integer, or it could be some sort of fraction or some sort of other real number. But as long as the variable itself is just itself, perhaps taken to a positive integer power, you're good to go. So notably, what you want to avoid is something like an x inside the exponent, a variable underneath a root, a variable inside a denominator, none of those situations. But otherwise, as long as it sort of looks like an x to the fourth or something like that, you're good to go. And then once we have a polynomial, we want to be able to talk about its different parts. So in particular, on an individual term, your coefficient is always going to be that numerical part of the term, so it's whatever is being multiplied by the variable. And it should be a real number. And by real, stuff like square root of 7 or pi is totally cool, but you shouldn't be having any imaginary numbers. The variable part is whatever is going to be your variable in the term. So in this case it's x, but it could be something else like an a, a b, could be Greek letter or something like that too. And then what's new is this idea of the degree, which is the exponent of the variable, in this case 4. In addition to talking about the different parts of a term, you can also talk about different types of polynomials. So a polynomial in general can have whatever many terms you want, but a monomial specifically is going to have 1. A binomial is going to have 2, bi being the prefix that always means 2, such as bicycle. Trinomial is always going to have 3, tri being the prefix that means 3, like tri-state area or tricycle. And all of these would be examples of those various types of polynomials. Also, you want to be able to talk about the different types of terms in a polynomial all put together. So for individual terms, we can talk about their individual degrees and coefficients. So for example, for this first term, his coefficient is 3 because that's the number out front that's being multiplied, and his degree is 7 because that's his exponent. For the second term, he's being secretly multiplied by a -1 when you see a negative x, and he's been secretly taken to the first power, because if you have an x by itself, it must have been x to the first power. So that's why he has a degree of 1, and -1 is secretly his coefficient. And then similarly, if you see a positive 7 by itself, well, that 7 must be secretly multiplied by x to the 0th power, because anything to the 0th power is 1, and we tend not to write the multiplying by 1. So he's a constant with degree 0, and he's his own coefficient. Now, for the whole polynomial, if we ask for the degree of the entire thing, the degree of a polynomial is the degree of its highest degreed term, which is more formally known as the leading term. So in this case, that leading term would be 3x to the 7th. So his leading coefficient would be 3, and his degree would be 7 because of that leading term. Now keep in mind that that does not change just because the numbers have been added in a different order. So in particular here, if I instead gave you this polynomial as 7 minus 3x plus 3x to the 7th, now he would still have a leading coefficient of 3 and a degree of 7, because that's still the largest power on that polynomial, which is why it's recommended that you get in the habit of rearranging polynomials into what's called standard form, which basically means all of the exponents on those polynomials, aka the degrees of each term, are going to be in descending order from largest to smallest. This one in particular also would be known as a trinomial because there is exactly 3 terms. Let's take a look at another example. So in this next example, he's already listed in descending order from largest to smallest exponent. And in particular, this first term is going to be your leading term because that highest exponent is 6, which means that the entire degree on the polynomial is going to be 6. Similarly, the leading coefficient also comes from that term, which means that it's 9, because 9 is the number being multiplied out front of that term. The constant is going to be whatever number is by itself. He's been secretly multiplied by x to the 0th power, so in this case that would be 10. And then you can talk about the coefficients on individual terms. Now the one that sometimes throws people off is if you have something like negative x cubed over 22, that's really the same thing as negative 1 times x cubed over 22, which by the associative property of multiplication you could rearrange to be negative 1 over 22 times x cubed, effectively sort of putting parentheses around that division there. Which division is the same thing as multiplying by a fraction. So that is why the coefficient on the third term would be negative 1 over 22. So keep in mind that even if an individual term appears to be being divided, that really means he's just being multiplied by a fraction. So let's go ahead and do a few practice problems. So I'm going to encourage you to go ahead and pause your video and try out these 2 practice problems, identifying the degree of the polynomial, the leading coefficient, and the type of polynomial he is. So for this first one, before I start doing that, I would recommend rearranging this in descending order. So in particular, that would be negative 8x cubed plus 7x squared plus 1. Notice how the minus sign follows that entire term, because he's really the same thing as plus a negative 8x cubed whenever you have minus positive 8x cubed written, which means the degree of that polynomial would be 3 because that is the highest exponent. The leading coefficient would be negative 8 because that's what x to the cubed is being multiplied by. And this would be considered a trinomial because there are 3 terms in the polynomial. For this next one, again, you want to make sure that you're doing the same thing. So you first want to rearrange him as negative x to the 6th plus 5x to the 5th minus x to the 4th, which means the degree of the whole polynomial is 6. That leading coefficient is negative 1 because of that negative in front of the x to the 6th really means he's being multiplied by negative 1. And he is also a trinomial because there are 3 terms. Remember, mononomial is 1 term, binomial is 2 terms, trinomial is 3, and then polynomial is the umbrella term that means any number of terms. So in particular, if it has 4 or more terms, it is just a plain polynomial. He doesn't have a different special name attached with him. For this last one, we can do a similar sort of thing. So we want to rearrange him where he's first 4x to the 4th, then minus x cubed, then minus x squared, then plus 7x, then minus 1. If there were any like terms to combine, I would want to combine those as well. There are no like terms to combine, so I'm good. So the degree of this polynomial would be 4 because the highest exponent is 4. The leading coefficient also happens to be 4, so his leading coefficient would also be 4. And he would just be considered a polynomial. There would be no special name for him. And do keep in mind that if you can combine like terms, you have to do that as well. Because if, for example, I had 7x to the 4th minus 2x to the 4th was my entire thing, he would not be a binomial because I can combine like terms. 7x to the 4th minus 2x to the 4th makes 5x to the 4th. So this would be a mononomial with a degree of 4 and a leading coefficient of 5. And you can also be asked about the individual degrees and leading coefficients of individual terms. So for example, on this third one, the second term would have a degree of 3 and a leading coefficient of negative 1. The third term would have a degree of 2 and a leading coefficient of negative 1. The fourth term would have a degree of 1 and a leading coefficient of 7. And the last term would have a degree of 0 and a leading coefficient of negative 1, and it would also be your constant as well. And they do want you to rearrange those before you start talking about the degree and leading coefficient of each of those individual terms. And really for those last ones, I should have just said the coefficient of that term, because technically the leading coefficient just goes with that first term, but the coefficients of each of those terms would be from order from the very first term, 4, the -1, the -1, then 7, the -1.